And now let us proceed with subtraction of integers. And here is the rule for subtraction of integers. So we add the minuend to the opposite of the subtrahend. And what do we mean by this minuend and subtrahend? So here, so let us have the first example. So we have a 43 minus 28. So the first number in this statement will be your minuend, while the second number in this statement is the subtrahend. And based on this rule, we need to perform an addition instead. So that means we will be changing the subtraction here to addition. And what do we need to add are those minuend and the opposite of the subtrahend. So the minuend is obviously 43, while we should take the opposite integer representing your subtrahend. And if this is positive 28, then the opposite of such will be negative 28. So with this, you will now be performing the rules of addition. And since we have two different signed integers here, then we must perform the addition of unlike signed integers, for which we have to subtract the absolute values of this number, starting with the larger absolute value, 43, while this one has an absolute value of 28. So this gives us 15. And since positive 43 has the larger absolute value, our final answer will be positive 15. And now let us proceed with the other example. So normally I am using a mnemonic device to easily remember the idea on how to subtract integers. And let us apply such idea instead for the next example. So you only need to remember this mnemonic device: copy, change, change. For which, what do we need to do for the first number here is to just copy that exact number, which happens to be 37. And we need to change the operation from subtraction to addition. And this is a negative 19, so we have to change this to its opposite, which happens to be positive 19. And now we have this addition statement. So since we have common signs, and easily we have the answer of 56. So the final answer is positive 56. And let us have the next. So here we have a negative 21. So we only need to copy this exact number, negative 121. So change the minus sign to plus sign. And here we have a 76. So change this to its opposite. And that becomes negative 76. And now we are adding same signed integers again. So the final answer would be 197. And let us have the fourth one. So we need to copy this exact number, negative 25. So change the minus sign to plus sign and change the negative 36 to positive 36. And we are adding this. So here we have an 11. So since positive 36 has the larger absolute value, the final answer will have a positive sign. Let us proceed with the multiplication of integers. So the rules for multiplication of integers, again, is divided into two categories. One, the multiplication of integers with like signs. So to multiply two integers having the same sign. So here we only need to take two multiplicants at the same time. So we multiply the absolute value of each integer. Then we need to affix or copy a positive sign to the product. And let us have the first example. So here we have a 23 times 34. So these integers have the same sign. So based on the rule, we have to directly multiply their absolute values. And here we have a 12. And here we have an 8 plus 1, which is 9. While this will have 9. While this will have 6. Adding all this together, we have 782. So for those of you who happen to have this particular way of multiplying this same numbers like this, let me demonstrate that you may also perform this kind of solution. So we are multiplying this 3 with the 4, and we have this to be equal to 12. While multiplying 2 with 3 gives us 6, so instead I am writing 0, 6. So multiplying these two numbers together, so 3 times 3 is 9, so I am writing a 0, 9. So notice that I am writing the answers vertically aligned like this. And now let us try to multiply this next set of numbers. 2 times 4, we have this to be equal to 8, and I am writing 0, 8. And adding all these numbers together, we have 782 as well. So this is just another way of multiplying integers. And now for our rule about the sign, we need to affix a positive sign to the product. So our product is 782. And this will be positive based on that. And let us have the next example. So here we have negative 32, but we will only write the absolute value, which is 32. This is negative 17, but we only need to write the absolute value, which is 17. So we multiply this directly based on the rule. And that gives us, so this gives us 21, 2, so this is 2, while this is 3, so we have this. Now, so for the other way of manipulating the same multiplication problem, so we are multiplying this, and that is 14. So this one is 3, while this one is 2, and this one is 21. And this gives us the same answer of 544. So again, going back to this rule about the sign of the product, it will take a positive sign. And this will be 544. Okay, so in multiplication, for as long as both of these two multiplicants have the same sign, the answer will always be positive, such as multiplying a positive number with another positive number, the product is also positive. So here we are multiplying a negative number with another negative number, the product will also be positive. And now, let us proceed with the multiplication of integers with unlike signs. So this time we have different signs, and notice that the first example has a positive sign here, the other one is negative. And for our rule, we have to multiply the absolute value of each integer, so same with the first one, but the difference lies on the rule about the sign of your product. So here we need to affix a negative sign for our product. And let us have the first one. So here we have 16 times 28. Okay, so I'm only writing the absolute value of negative 28. So multiplying this together, so here we have 48. So here we have 8 plus 4, 12. We have a 12. And here we have a 2. Okay, plus 1. Adding all these numbers together, we have, so if you, okay, so we have the same number of 448. So based on the rule, since we have different signs, one is positive, the other is negative, the product will take a negative sign. So we write negative 448 for our final answer. And let us have the next one. So we have a negative 23, but we only write the absolute value. So here we have a 14. The absolute value is also 14. So multiplying these two numbers together, we have, so here we have a 12, here we have an 8 plus 1, 9, so we have a 3, then 2. So adding all these two numbers together, we have a total of 322. So we obtain the same number, 322. Since we have different signs based on the rule, we take a negative sign for our final answer. And we have a negative 322. Now let us proceed with the division of integers. So let us have the division of integers with like signs. So to divide two integers having the same sign, we need to divide the absolute value of the dividend by the divisor. And based on the rules of signs, we need to affix a positive sign to the quotient, right? So that means a positive sign number divided by another positive sign number will have a positive quotient. So here we have a negative number divided by another negative number. We also have a positive quotient for this. And now let us have the answer. So having the absolute value of 126, having the absolute value of 3, written like this, and now we divide these two numbers. So having it all together, divided by 3, we have a 4, so we can check for any remainder. So there's none. So we bring down the 6, and 6 divided by 3 is. So obviously, we have an answer of 42. So we have already learned that this will take a positive sign, so the final answer is positive 42. Let us have the next one. So here we have a negative 6,834. So writing only the absolute value, 6,834. And we divide this by negative 17. So we only write the absolute value. Now, let us divide this. So 6 divided by 17, obviously, cannot be. So taking these two together, we have 68 divided by 17. 7 should be 4. So let's check. We have 28, 68. So the remainder, so there's no remainder. So bringing down the 3 together with the 4, so we have this equal to 2. Okay? So the answer would be a positive 402. And now let us divide these integers having different signs. So divide the absolute value of the dividend by the divisor. And we need to affix a negative sign to our quotient. So for number 1, we have different signs. So our final answer will take a negative sign. So this one is negative, the other one is positive. So your final answer will also take a negative sign. And let us try to divide these two numbers together. So 36 divided by 9 will give us 4. So the final answer is negative 4. While for the other one here, let us do some scratch work. So writing only the absolute values like this. And now let us try to divide. So 21 divided by 6. So the nearest quotient is 3, having a remainder of 3. So since we cannot divide this two, we bring the 3 down here, and 33 divided by 6 will give us a 5. And obviously 5 times 6 is 30. So the remainder is 3. Still, we have to bring this number down, and finally we have 36 divided by 6, which is 6. And there will be no remainder for this. Now, the final answer would be negative 356.